So we have our two data sets inside of different Spark data sets. We have one for our county data and one for our series. Our series actually still has a header that we don't like. We could, of course, pass this through a filter to get rid of it, but since we're probably going to join it on the series ID with our county data, and none of these values were integers, they were all strings, there's not a strong motivation to me for getting rid of it at this point. We want to do the join. Okay, so we have a bunch of stuff in our county data. We have our different series, and I would like to line up the county data series because they have an ID with our series IDs, so that we can basically associate all of the data with the county that it came from. And we're doing this once again with the typed transformations. So whereas previously, I'm just going to call this joined 1. Previously, we might have taken our county data and called join on series, and then we'd have to pass it some information about how we were joining it. There were different ways that we could do this. I could do it like this. Now the thing is, this would give me back a data frame because join is a one of the untyped transformations. The typed form of join is join with. Unfortunately, it doesn't like being passed a string for a column name, and I have to say this does upset me because I really did prefer that. And so there's this interesting question of, okay, well, how are we going to join these if I can't just give it the name of a shared column ID? Well, what if I make it like that? Because it turns out, well, we could look in the API. What does join with want? Join with takes the other data set and a column. Okay, seems reasonable. I gave it a column instead of a string. So we come to here, and let's go ahead and do join.show. I'm going to take out the series show, and that was joined 1. And we run it. And failure. Okay, well, what's unhappy with this? Clearly it's the join with, since that's what we just added. Reference ID is ambiguous. It could be ID 4 or ID 55. Well, I could, and what I really want is, in fact I want 3 equals here. I really want the ID from county data to be equal to the ID from series. That looks like a way we might type that in. Of course, you can kind of already tell. It's like saying check for A equal to A, which is always going to be true. In fact, we get a warning here. Warning, column name constructed trivially true equals predicate of ID equals ID. Perhaps you need to use aliases. Indeed, our problem here is that I have 2 columns that are named the same. And while with data frames, this could bite you occasionally, and you'd have to use aliases. But the easy way around it with data frames was just to pass the shared name of a column, and everything was happy. That isn't an option for join with. Okay, and so how do you get around this? It's tempting, and one of the possible things that might jump to mind would be to say county data of ID joined with series of ID. We'll run that. Because if this references the column from one data set and this references the column from another data set, then that should get us the result that we want. This is a fairly large join because that county data is fairly large. It's worth asking how large. WC of LA.data 64. there are over 4.6 million records in this county data. It's an interesting question of should we do something to trim that, to potentially play with these more, maybe sample it down or something along those lines. This is taking a while, but we didn't get that warning. Okay, so this looks like it will probably work. It's just going to take a while to happen. Oh, and there we go. Maybe it didn't work. Okay, so I got it did spend a lot of time to give me back kind of a nothing, and it says _1 and _2. One of the things to note about the join with is it gives you back tuples. So we get the LA data and the LA series as separate things. In my experience, having two columns that are named the same, while that's excellent for data frames, it can cause problems for data sets, like what we're seeing here. The other issue that came up for a different data set that I was playing with is when you pull two different basically two different data sets out of a single data set. So I have a single big data set and I filter it in different ways and I want to join on those. That just doesn't work well at all using the typed data sets. So one possibility here would be, let's actually give this a different name. So now I have the ID, which is the county data, and the SID. And by avoiding having the same name, so all the other elements in here have different names, by avoiding having the same name, we make it so that it's easier for us to give unique things to Spark. This is a potential downside of using the typed data sets, but it's something that you should be aware of and that you potentially have to deal with. Still haven't thinned out that data. This might actually be a good time to talk about randomly thinning data. If we go look at the data set, there are random splits, there's a sample. There's both sample, you can do with replacement or without, and a fraction of what fraction of things you wanted to sample. So if I want 10% of the counties, I could pass in 0.1. What with replacement means is when it does the sample, after it pulls something out, does it stick it back in so that it can pick it again? For certain data sets that the replacing values make sense. This does not happen to be one of those data sets. So it might actually be a good idea for us to sample our data set so that some of these operations could go faster, still having the problem here of joining these data sets. Joining on the type data sets is a more challenging operation because we can't just specify a column to deal with. We'll come back and we'll look at this more in the next video.